Hi, ladies and gentlemen. Have your yellow worksheet out in front of you. We are going to work through these 5 rules together and get you some examples that you can use on your quiz tomorrow. All right, so let's get going here with some examples, or that first rule, that product rule. So remember, you've got x to the a power times x to the b power. We've got a cool rule that says you can take x to the a plus b power. All right, so anything with the same base, if you're just multiplying those, you can add those exponents. Couple examples to back this up. I want you to write these down. We're just going to do a couple here. First one, just keeping it simple, looking at g to the 5th power times g to the 4th power. So noticing they've got the same base, you can then add those exponents. So in your notes, I'd like you to write down that we can just go g to the 5 plus 4 power or g to the 9th power. Done. One more example. Make this fit right nice and neat. Like I said, I want to do at least 2 examples here in each column. So the next one, in parentheses, you've got a negative a to the 3rd, b to the 4th, and then we're going to times that by 5 times a times b to the 6th power. And once again, write nice and neat. You probably have more space with your pencil than I do with my pen here on my board. First thing I want to point out, when you've got coefficients included with variables, you need to make sure that you multiply those coefficients. What's tricky though is what's hiding here with that negative is a hidden negative 1. So plop in a negative 1 right in front of that a to the 3rd. We need to take that negative 1, and then we need to take that 5, and the only sign here is to multiply those two numbers. So negative 1 times 5 is going to give you negative 5. Then you got to find your like bases. So in this case, a to the 3rd, right here, times another a, which is a hidden a to the 1st power. We can add those exponents and end up with a to the 4th power. So that's just adding this 3 plus 1. All right. Then last one, b to the 4th times b to the 6th. We can take that 4 plus 6 and add those together. We end up with b to the 10th power. All right. Final answer then would be negative 5 times a to the 4th times b to the 10th power. Done. So what's tricky there, look out for coefficients, look out for the hidden negative 1, multiply those, and then add any like bases with those exponents. You can combine those all together. All right. I'm just going to get rid of this to give myself some space. Now, next rule, check it out. That power rule, when you've got in parentheses x risen to the a power, and then that's risen to the b power. We can take that b and we can distribute that into the parentheses to that base. And when you distribute, the rule states we can take a times b and multiply those exponents together. So quick little rule if you want to write that down. When you distribute, remember that means you need to multiply. All right, couple quick examples here. In your parentheses, if you could write w risen to the 5th power, and then that is risen to the 2nd power. Once again, I see now, if I'm expanding, I could write w to the 5th power 2 times, that w times w times w times w times w, and write that again. That's your base, risen to the 2nd power. Or with that rule, we can just take w to the 5th power and times that by 2. So we're distributing that 2 to that 5. So final answer is w to the 10th power. Done. One more example, I want to make it a little bit trickier, putting in some coefficients. So in parentheses, negative 4 times x to the 3rd power times y to the 4th power, and then I want to raise that to the 2nd power. When you've got coefficients and you've got multiple bases here, just a reminder then you need to take this exponent on the outside and you need to share that with every single base. So this gets tricky because we've got to take -4 in parentheses to the second power. You've got to distribute that 2 to the x to the third power, so x to the 3 times 2 power, and then take y to the fourth power, or y times 2 power. So when you then simplify, here's what's tricky. Once again, that -4 to the second power. Using your brain, ladies and gentlemen, -4 times -4 should be a positive 16. If you use your calculator, make sure you put parentheses around that -4. So that's 16, and then times x to the 6th power, y to the 8th power. This is your final answer right here. Awesome. All right, keep trucking. Go into that quotient rule now. Having x to the a power all over x to the b power. Remember, when you've got the same base in a fraction, we can take those bases, or those exponents, and we can subtract that numerator minus the denominator. All right, so as a rule, we could take x to the a minus b power. Okay, couple quick examples. I'm just going to erase this so I've got some more workspace once again. Sorry, I know that's not ideal because you can't see all the examples now. But couple quick, here we go. So first one, f to the 6th power all over f squared. Right? You've got one base, f to the 6th all over f squared. If I've got the same base, I can subtract those exponents, f to the 6th minus 2, meaning I've got f to the 4th power. Done. This would be your simplified answer. All right? One more of these just to make sure we've got one with a coefficient. If you can't make it fit on the front of your yellow worksheet, flip over your worksheet and just add that to the back. I'm going to just erase this one and now put in one with a little bit more coefficients and variables. So -15 w to the 5th times x to the 3rd. I want that all over 5 times w x squared. So check it out. We've got coefficients, we've got variables, w's and x's. Now we want to simplify as much as possible. So taking that -15 divided by 5. Those coefficients, we just want to divide like normal numbers. We end up with -3. Now look at your like bases. I've got w to the 5th all over w. Remember, hiding there is w to the 1st power. So we can subtract those exponents, 5 minus 1, and we end up with w to the 4th power. Same thing with our x's. We've got a base of x to the 3rd all over x squared. I'm going to subtract away those 2 on the bottom. I end up with x to the 1st power. Now here's what's kind of cool. You don't need that 1. So if you just want to write -3 w to the 4th x, this would be your final answer. All right, last 2 rules. These are the ones we talked about yesterday. Want to make sure we got those straight. That negative exponent rule. Remember, we are not allowed to have negative exponents, so x to the -a power is illegal on your quiz tomorrow. You are going to want to take that, anything risen to a negative power, make it into a fraction, and then take the reciprocal of that fraction. When you take the reciprocal, so 1 over x to the a power, that power becomes a positive power. So x to the -a all over 1, if you would do the reciprocal, becomes 1 over x to the a power. Okay, couple examples, starting with just b to the -7th power. Basic, but just in case you see that on their quiz tomorrow, same thing, you're going to want to take that b to the -7th, make it into a fraction. So make it over 1. You're going to want to do the reciprocal, so flip the numerator and the denominator. You've got then 1 over b to the 7th power. Done. Now it's a positive exponent. You are simplified. That's as far as you can go with that one. All right. Once again, flip over your paper if you don't have enough space. Couple more I want to try with this one because this gets tricky. With our negative exponents, I want to show you this. If you have p all over q in parentheses, then that is risen to the -3rd power. You haven't technically seen this yet, but when we have a fraction in parentheses risen to an exponent, It's still that distribution property, that power rule from up above, but you need to take that -3 and you need to distribute it to both bases. So you need to distribute it to P and to Q. So that would mean we'd have P to the -3rd power all over Q to the -3rd power. But then both of these powers are illegal. We can't have negative exponents. So now we got to think, okay, we got to do the reciprocal. So the reciprocal of P to the -3rd, which is in the numerator, has got to go to the denominator. And the reciprocal of Q to the -3rd that's in the denominator is going to need to go to the numerator. So basically this just becomes a big flip-flop. We're going to end up with Q to the 3rd in our numerator all over P to the 3rd in the denominator. And now it's legal because you got positive exponents. There's no like bases. This would be your final answer. That's an important example. Hope you got that down for tomorrow. All right, one more with negatives because I just want to make sure we got it. This one I know is tricky. Last one, once again, make it fit somewhere either on the front or on the back. One more parenthesis. I've got 5w to the -3rd power, and then I'm going to raise that to the -4th power. So once again, when you've got that parentheses risen to the -4th power, you do have to distribute this -4 first. You can't expand, especially with negative exponents. So we're going to share that -4 with that w to the -3rd, and we got to share it with that 5. So distribute to both of those bases. This gets tricky because now you've got 5 to the -4th power. Yuck, illegal. And then what's kind of nice though is you've got w to the -3 times -4 power. Since you've got a negative times a negative, that's actually going to turn us into w to the 12th power. Nice. W to the 12th power is legal. What's not is 5 to the -4th. So we are going to have to make just that into a fraction. Take the reciprocal, meaning you got to drop that into the denominator. And so now I've got 1 over 5 to the 4th power, and we got to times that by w to the 12th power. Last thing we got to do, once again, look out for any bases that are numbers risen to exponents, because this is actually something we can simplify. All right, 5 to the 4th power ends up being 5 times 5 times 5 times 5. So please don't tell me it's 20. That ends up being 625 in your denominator. And then we're going to shift this w to the 12th into the numerator. So you end up with w to the 12th power all over 625. That's your final answer. All right, last example. I'm going to get rid of this and make sure we're good to go here. Remember that fabulous rule, zero exponent rule. We've got x to the 0 power. Remember, anything to the power of 0 is 1, right? It's not 0. Don't make that mistake on the quiz. Anything to the power of 0 is 1. Kind of nice. Okay, a couple examples. Think about this one. H to the 0 power. Nice. Remember, it's just 1. Think about, how about in parentheses? You've got 7 times x times y, and then all of that is risen to the 0 power. Once again, hopefully, using that distribution property, all of these would then now be to the 0 power. That would just be 1. All right? Be careful, though. One last example, if you can make it fit. Think about this. If I were to give you a problem that was 5 times x times y to the 0 power times z, right? In this case, not all of these are to the 0 power. The only one that's to the 0 power is that y to the 0 power. So that becomes a 1. Everything else has to stay the same. So the final answer would be 5 times x times z. That would be your final answer. All right, ladies and gentlemen, I'd like you to keep this yellow piece of paper safe. You may use this as kind of a cheat sheet or notes on tomorrow's quiz. What's coming out to you next should be a pink review worksheet. That pink review worksheet is worth 5 quiz points. Please make sure you get that done and be ready to turn that in tomorrow before the quiz. Please check Schoology as you work. The other thing, I guess, just a couple quick reminders. Make sure that you also bring a book to read tomorrow for after the quiz. Make sure you also have your notes, your calculator, all that good stuff, and then a charged iPad for your vocabulary quiz. All right. Hope to see you tomorrow.